Hello, this is Dr. Wozin and welcome back to the second part of our tutorial number 3, which is on power driving. This is the model that we are going to go and model into Praxis. We are going to do a full model, but you can model a symmetry of this model from there. So we are going to go to Praxis and model the full model, assuming the model to be 30 mil. We are going to drive this our concrete panel halfway to the model. And these are the material properties which we are going to use for the soil material. So now if you go into Praxis now, so go into Praxis, agree. So we're going to start a new project. So we are going to name this power driving, and I will also mention that dynamic, since as you drive the power equals a dynamic action on the soil. As we remember, we discussed that we are going to do an axis symmetry model. So we're going to change this to axis symmetry. We discussed what the difference is between axis symmetry and plane strain. We're going to leave our dimension as it is here, meter, our units to be meter, kilo as it is. Under the contour, we are going to use the maximum. We assume that we are going to use thickness of 30 mil. And we know that our model is 18 meter thick, so I'm going to put 18, and then everything else you just leave as it is. So this add one is required for us, so we click OK. Now to draw the model, we go on that structure line. Now we are going to create our soil profile, so we go there, draw 30, and up 18. And back up here, 30, 18, and there we go. This is our soil profile. So now we are going to draw our pile. Now our concrete pile is halfway and it's down 11. So 15 down to 11. There we go. And we know that is 0.4 meter thick, so you can zoom in by just scrolling on the small hole on your mouse just to zoom in to see a bit more clear. So this does not let us do 0.4, so I'm going to put it at 16. Right click. If I come out using that arrow, click on this last point here, it gives you the dimensions. So we are 11 and that is 16, so we want it to be this point here is 15, 11, and here is 16. So from 15 to there is 0.4. So we're going to change it to 15. Oops, no, leave that at 15 because it's going to change that point. So we're going to change, click on that point, and put here 15.4. There you go. It changed dimension automatically for you. So I'll go back to my line. Zoom it to know where I am. There we go. Go back 15.4. You can see again, zoom in only 15.4. There we go. So we've drawn our pile. Now we are going to do the interface. So to do the interface from the pile and the soil, go under where you see this sign here, click on it. It gives you different options and say create interface. Now we want to create a negative interface, so go zoom again just to see what we are doing. As you are creating interface, it will tell you whether it's going to be a negative or positive. There we go. That was a negative interface. Do the same thing for this one. There we go. We've created our interface. Now we are going to have a load be applied to this pile. So if you go under loading, create a load. You don't want a point load, you want a line load. and this landlord is going to be on top of our pile. So if you just go on top of the pile, zoom again, try to zoom so that I can see what I am doing and where I'm doing it. There we go. So we have our model there. Now we turn our pile, we turn our soil model here. So now we need to assign, we know that we have a 2-layer. We know that there's a clay and sand, and we know that the clay is 11 meter thick. So I'll go back to the line. Bear in mind that you could have drawn that before drawing all this, but it doesn't matter. So far all the model is drawn all together. So we know that it's 11. There we go. So separated our model. So now the top here is our clay and that is our sand. So now to be able to assign the properties, as you know, we go to our soil polygon to identify each our model. So we go there. So go around square here, and this is going to be our sand. Same for clay. Now what you can do is I can go all around this, say, a clay, or I can just go around our pile, however I want to do it. So I'm going to go around the pile. Bear in mind that you can still go now you see what I mean. So I've went around the pile. Now you could still go around and make this a whole clay. So this part is going to also assume that this is our pile, so it's clay, and then we'll do the same. We just highlight the pile to be separate. Since our pile is concrete, so I've done that one for our pile. There we go. Now kick out of it. Now we have separated our clay, sand, and our pile. Now we're going to add our properties now. Click on show material properties. And that's the interface create. So we're going to add for our clay. If there are small column and it's on train, again the properties are on the table in first slide of our tutorial. Now here I'm going to change the color to be kind of this color. Now the unsaturated here is 16, that is 18, saturation is 18, Young's model is 5.0, we have our Poisson's ratio to be 0.3, on drain just 1.5. We have the Young's model increments, which should be latest 1.0 power 3. The reference is 18, and you can see that I should add it just for plate here, so that's fine. Our session increment is 3. Now there's an interface where, because we have an interface between the soil and the pile, so we need to put an interface, enter a value of 0.5. And the K0 procedure, you can't leave it as star, but in this case it's 0.5. Now let's not forget to sort our soil here. We know it's clay, so that's fine. The permeability was not given to us, so I'm going to put it as the default by selecting that for Platts to set up the default value. So we have our clay, so track it there. So you see it track all over, but it does not highlight the pile. Now new one, sand. Our sand is a hardening soil model. just because since our power is at the top of the sun, so we bring the sun to be a bit stronger than that. Make the property of the sun to be that. So we have that on join A. Excuse me. On join A. I'll leave the color like this. So let me put it like that. Yeah. 70, 20. Now, if I 50, 5.0. That is 5.0. It automatically populates exactly the same thing. That is 1.5. Remember, some parameters you obtain the lab, some you assume them. That was a mistake. So that is 0.5. Now our V dash reference is here. So let's see if self control as it says. Friction 31. We have another parameter here that is given to us. That parameter under the small string. Under here you can see as you add. On the right hand side you plot a graph there for you. 0 is 1.2. Because this represents your string. Want to see it? Let's go and show you that. Give the intervention that should be rigid. That is 0 point automatically calculated for you. Now under here I'm going to leave as course, and if we don't have permeability I will use a default value. That is our sum. Now next bit we are going to do is our pile. Now we've explained our pile is going to be taken as linear, elastic and non-porous, because we are modeling the concrete pile. So we are going to use, I'm going to take a color for that. And we don't need the saturated unique, but sometimes when you add values, each class asks you to add a saturated value, just add a value. But just make sure that this activated properly. If not, if you say the wrong finish type, the pass will ask for saturated one. As you can see, it just self-generated. Now we need that is 3.0 also. And that is 0.1. Everything that is rigid, that is down. This is concrete, so we don't actually have anything. So we leave everything else as it is. Do not change anything. So now we drag. Now for me to be able to make sure I'm dragging to the height possible, I've zoomed it just so I can see properly. Change plus. There we go. Now we have this is our model. We have put our material. So in the next part of our video, we are going to go through mesh and the calculation stage.